Hello and welcome to the final vodcast on potential dividers, just section 5.2e from topic 5, electricity and magnetism. One of the skills that's mentioned is comparison of a potential divider and the advantages over using a static resistor and a series resistor. And here we have an example of that. Suppose we want to control the potential difference across a lamp. We do this because we want to control the brightness of the lamp. Suppose our lamp has a fixed resistance of 20 ohms and we have this variable resistor that can go to 0 to 20 ohms. Now, at 0 ohms, then the output is all through the lamp or across the lamp, so it gets the full 12 volts and it will be as bright as it can be. However, if we increase the variable resistor's resistance to 20 ohms, then now the output is being shared between the variable resistor and the lamp goes down to 6 volts. So it has got dimmer, but it's not gone all the way to 0. We can, of course, increase the resistance. We could put a different variable resistor in if we have one available, but even there, the problem is that no matter how large you make it, it's still going to have some potential across the lamp. It's never going to go completely to 0. So our alternative design looks like this. We can use the same component. This is actually physically the same device, the same potentiometer that we're using. We're just wiring it in a different way. We're wiring it in such a way that the lamp is effectively in parallel across part of the variable resistor. You can see that in the diagram here, the lamp in parallel. Now it's a bit difficult to see because you have the slider at the top here. But the idea is that you can slide the slider down here, and so this comes lost cable here, it comes along the thick part of the device here, down the slider, and then it's just in parallel with a certain section. So you can think of it, wherever the slider is set, as the slider separating our potentiometer into two resistors, R1 and R2, if you like. As you move the slider, the values of R1 will change, the value of R2 will change, but R1 plus R2, the total resistance of the thing, must stay the same. Okay? So, for example, let's start. So it splits into two. Suppose we've got a 20 ohm resistor, so it could split it into two sections here. We'll mark that section X, just a point along which it goes, and below the bottom resistor will be X ohms and the top resistor will be 20 minus X ohms. Now if we put our slider all the way to the bottom, then it's not across or parallel to any of the variable resistor, the potentiometer part here. So you have the full 20 ohms in series, you have effectively a short circuit here. If you put this across a short circuit, then it's not going to have any effect, and Vout will be 0 volts. All the current will go through here, none of it will go through the secondary circuit here. All you're doing is using the resistor to heat up your environment. But if we slide it up, say we slide it 3/4 of the way up the potentiometer, now X is 15, so this is a 15 ohm resistor at the bottom here, the part that it's in parallel with the output. And the part that's in series left over is 20 minus 15, which equals 5 ohms. And what will Vout be now? Well, now we can use R2, R1 equation here. 15 over 5 plus 15, which is 75% of 12, gives us 12 being the input, gives us 8 volts of output. And if we put it all the way to the top, then our Vout is completely in parallel to the 20 ohm resistor, and therefore the total output will be 12 volts. So just to summarize, a potential divider gives you the possibility of having the full range, the potential difference across the output from 0 through to 12 volts, using, don't forget, the same components just wired differently. The same 0 to 20 ohm variable resistor, the potentiometer, if wired as a potential divider, will give you a 0 to 12 volt range, whereas if it's used as a variable resistor, it only has a 6 volt to 12 volt range. Okay, that's potential dividers done for now. Thank you very much.